Hello, everybody. Today we're going to talk about indefinite integrals and mainly antiderivatives, common antiderivatives that you should know. So let's start before we talk about antiderivatives. Let's just take the derivative of a few functions. If you take a look at the top here, if I give you f of x equals x squared plus 1, then the derivative of that function would be 2x. The derivative of 1 is 0. For the second one, kind of the same idea. Derivative of x squared is 2x. Derivative of negative 5 is 0. And derivative of x squared is 2x. Derivative of 1,000 is 0. So here's the idea of if you have a constant added to the end, we know that the derivative of that constant goes to 0. Now, why is that important, right? Let's say I want to do the antiderivative. Now, in the previous lesson, we learned how to take the antiderivative of a power, okay? And if I were to do this, if I were to say f of x equals 2x, remember, we are going to say, we're going to raise it up a power and multiply by the reciprocal. But if you multiply 2 by the reciprocal of 2, you just get 1. And we're going to account for a plus c there. The reason being is because we don't know if the original function had a constant or not. Okay, so again, you can see it here just with the common constant, or you can have a specific constant, but we don't ever want to put a specific value in there. We always want to just use that c unless extra information is given. Okay, so integrals without a boundary or limits are indefinite integrals. Okay, so definite integrals have limits, indefinite integrals don't. Whenever you have an indefinite integral, we always need to use a plus c. And in the previous lesson, we went through the antiderivatives of power functions and sine and cosine. In this lesson, we're going to cover all the other antiderivatives and then try to put them into use in a few practice problems. So the antiderivative of e to the x is still e to the x, but don't forget your plus c. The antiderivative of a to the x is a to the x over the ln of a. Don't forget your plus c. All right, and let's see if we can put these to use, to practice. So find the general solution of the antiderivative. So integrate 7 to the x power. So if I integrate 7 to the x power dx, that is still going to give me 7 to the x all over the natural log of 7 plus c, of course. Now, here's the nice thing. We can always check our answer by taking the derivative, and I'm going to write that natural log of 7 in the denominator as a fraction, right? So if I take the derivative of this, the 1 over natural log of 7 is just a constant multiplier. We don't need to take the derivative of that. So that would still be there. And the derivative of 7 to the x is still 7 to the x times, the ln of 7. And if you reduce this, you get back to 7 to the x power. So again, if you ever want to check your answers, you can always take the derivative and we can get back to where we need to be. Okay, now there are some times where we want a particular solution. So if you were to take a look at here, I give you f prime is e to the x minus 2x squared. So that way I want to find f of x, right? So f of x is going to equal the antiderivative of e to the x minus 2x squared dx. Use your parentheses. All right, so we're going to do the antiderivative of that, which is e to the x minus, now we're going to raise this a power. We're going to multiply by the reciprocal. So I'm going to end up getting a 2/3 in front plus c. So my function as of right now is e to the x minus 2/3 x cubed plus c. Now what they told us was f of 0, right, was 4. So if I plug in 0, I get 1 minus 0 plus c, or in this case, c would be a 3. So my function, I'm going to change colors here, is going to be e to the x minus 2/3 x to the third power plus, in this case, we have 3. So we can find, so I gave you a little extra here, okay? And I can end up finding the value of c. All right. So the antiderivative of 1 over x is the natural log of x. And actually, to be more specific, it should be the natural log of the absolute value of x plus c. So if I were to do this, the antiderivative of 1 is just x. And actually, I'm going to write this off to the side just so you can see it a little better here. Do you see how this is x to the negative 1? If you were to try to do a power rule here, I'm going to get x to the 0 times 0. It's going to make this whole term go away, and that's not what I want. In this case, I'm really going to write this as, I'm going to think about it as 5 times 1 over x, which in that case would be minus 5 natural log of x, and then you got to have your plus c at the end. Okay? Now let's say I have one that's a particular solution. So f of x is going to equal the integral of 2 over x plus 6 over x squared dx. And if I do this, I'm going to write this a little better. Now, you can see just when you have 1x in the denominator, that's going to be the natural log. But this over here is not a natural log. It's like squared in the denominator. So my antiderivative would be 2 natural log of x. This should be absolute value over here, by the way. Plus, now I'm going to raise it a full degree, so it'd go to the negative 1 power, multiply by the reciprocal. So that's actually going to end up giving me a minus 6 plus c. So this would be my antiderivative. Now, it did want the particular solution, so I can say f of 1 is equal to 2 times the natural log of 1 minus 6 times 1 to the negative 1 plus c. So I know that's a negative 7. 2 times natural log of 1 is 0 minus 6 plus c. So if I add that 6 over, I know c has to be a negative 1. So if I go back up here, all I'm going to do is put in my negative 1. Okay? And that would be my function. So again, general solution is when I have the plus c in it. A particular solution is when I give you that extra information to find that c value. All right, so trig integrals. So yesterday, or well, on the previous video, the antiderivative of cosine is sine. The antiderivative of sine is a negative cosine. Secant squared is tangent. Cosecant cotangent would be a negative cosecant. Secant. And then we have negative cotangent. Oops. I almost put cotangent squared. There we go. Negative cotangent. All right. So those are the derivatives that you need to know. Okay. Or antiderivatives that you need to know. So let's see if we can practice with them. So if I were to take this for number 5, I'm going to take that 3 out front. And I know the antiderivative of secant squared is just tangent So I get a 3 tangent of x plus c. So this would be my antiderivative. All right, let's keep going. So dy dx equals 1 minus sine. So I know y is going to equal the integral of 1 minus sine of x dx. So I know y is going to equal x. The antiderivative of a negative sine would be cosine. Oops. I didn't need the integral symbol there. But they gave me a starting place, right? So if I know that my output is going to be pi minus 2 when x is pi, so if I subtract my pi, I get a negative 2 equals a negative 1 plus c. So c is going to be a negative 1. So I know my function would have to be x plus cosine x minus 1. And that would be my original function. Okay? Inverse trig. Okay, now look at the way this is set up. The derivative of sine inverse is a 1 over square root 1 minus x squared. We're not going to do secant. And actually, I would prefer this to be a cosine. So we're going to call this cosine inverse. And this is going to be a negative 1 over 1 minus x squared. And then tangent is a 1 over 1 plus x squared. So you don't need to know secant for your AP exam. All right, I'm going to cross this off. All right, so if you take a look at number 7, this just has to be sine inverse of x plus c. Okay. All right. Number 9, we can separate rational functions. And what that means is I am just going to divide each of these terms separately by x. So whenever you're dividing by just one term, you can separate those apart. And now I can integrate each piece. So this would give me an x squared, 3 over 2, because that's multiplied by the reciprocal. X, now you have to be careful. Remember this when I just have x in the denominator here, this is going to give me the natural log plus c. So remember that from an earlier problem we did. Okay, now I can also distribute, right? So I'm going to show you kind of how this works. So if I distribute this, I get 3x to the 3 halves, because x to the first times x to the 1 half, you would have to add their exponents. And then 3x times x squared is a 3x cubed. So now if I take the antiderivative, I'm going to get x to the 5 halves multiplied by the reciprocal. So 3 times 2 fifths would give me 6 fifths. Plus now x to the 4th reciprocal, 3 fourths plus c. Okay, and that would be my answer. All right, now there's a bunch of practice here for you to work on, okay, with answers at the bottom. Actually, the answers I've attached in Google Classroom. So you can go through, you can take a look at each one of these. Feel free to email me if you have any questions. And hopefully you guys will become master of antiderivatives.